Alright, boys, so we have some big developments going on here. I'd like to catch you guys up real quick. Um, Alright, so there's this YouTuber I've been following, and the YouTube channel name is The Robot Studio. He's a world class roboticist who's very experienced. Unlike me, I'm not so experienced. He's got a lot of history with successful humanoid robots. He's been part of teams that were funded for humanoid robot development by, I think, governmental funding. He was partnering with different universities, and so he's got like legit chops in the field. And he's been making tons of really cool humanoid robots, and it's been very inspiring. And he's also been answering a lot of my questions on his YouTube channel whenever I have questions. So his most recent project he called Hope Light, and it's kind of like a half humanoid sized robot, and it's going to be just on a hoverboard instead of having walking legs for now. He said eventually he'll give it like working legs. He said, and I thought maybe I should follow along with this one and actually make it because it's open source, and he's doing all of his projects open source. Um, but as I got into the nitty gritty of what he's doing, he is taking away too many degrees of freedom from the hands and wrists for my comfort. It would be less capable of useful work. It would be more of a novelty or toy at that point. So I realized I can't just copy verbatim, which I wanted to do. I just wanted to copy him, learn from him, and actually do one of his open source humanoid robots. But like I said, that's now not a good idea because if I'm going to do a robot, even if I'm just following along with somebody else's, it has to be able to do useful work when I'm done. It has to. Because there's no point to build a robot in my site if it can't then do work and help me. So the whole point of that idea was this: to create something a little faster, a little easier than my long-term dream mega project of having a super silent, super awesome, capable of everything robot that's human speed, human strength, or higher in both categories. Just like the cream of the crop, shooting for the moon stuff. I thought, it'd be kind of cool to have something several notches down from that, but that's still really good. Um, as a learning environment where I don't feel so pressured to make it perfect, but I can just kind of wing it and go fast and mess up a little more. I just feel like I've pigeoned myself into so much perfection that it's slowing me down so much, trying to find the perfect way to do everything. Um, so, anyways, with this, we're going to take a lot more shortcuts. I'm going to be loosely following that guy, but kind of not. It's kind of going to be a hybrid between what he's doing and what I've been doing. Um, this robot's name, though it's not really Hope Light, I mean, I am going to be following along with him, maybe trying to keep his pace, maybe trying to do what they're doing, but with my own style, my own twist. I really am not following what he's doing very much at all, but I am going to be following certain aspects of it and paying attention to what he's doing. I'm going to be following along, but not really copying. It's still going to be my own thing, but it's going to be a dumbed down, let's say half performance level with compromises taken. Still higher level than his, but half the performance of my ultimate ideal, which I'm still working on. So the Adam robot, the Eve robot, and the Able robot are still greenlit, still not changed. This fourth robot, which is going to be a quicker learning experience, just get something done, have some results a lot quicker. This one's going to be not using the top of the line approaches. It's not going to be using a human-like skeleton, which is a big change, and it's not going to be using the very best brushless DC motors. Instead, it's going to be using DC motors. We're going kind of backtracking with that. It's a lot easier to do the electronics for the DC motors, and these DC motors can already have gearing, so I don't have to worry about down gearing. Now, it is going to be metal gearing, so it's going to be loud, but that's okay. Now, right now, I'm looking at using N20 motors. This is the kind I want to use. 3 of these is equivalent to SC009. No, SC0009. VTech, I believe it's called. VTech motors, which is the motors that the Robot Studio is using for his finger actuations. 3 of these take up a smaller form factor than the servos he's using, and yet will provide 13% more power. And I did that calculation here, and you can see okay, so you've got SC0009, which is 30 RPM. It's 3.5 kgcm. The one I'm looking to use is the N20, which is 66 RPM. It's 0.5 kgcm. So by stock, his is 3.5 kgcm, and I'm at 0.5 kgcm, so he's 7x stronger. But that's at half the speed. He's at half the speed than mine. So he's really only, as far as total throughput, 3.5 times stronger. Once you start messing around with down gearing and stuff, we can make that up a lot. So 1 centimeter is the stock radius, because it's kgcm, that's based on 1 centimeter. Stock radius for torque measuring. He's going to use a 2.5 centimeter diameter winch for his, which he usually does. That's my estimate of about how big it is, which is 1.25 centimeter radius winch. This cuts his torque down since he's trying to pick up speed and trading torque for speed. And so 3.5 divided by 1.25 is 2.8 kgcm, which is his final torque, since he traded some of his torque down for speed. I'm going with 1 centimeter diameter, which is 0.5 centimeter radius. So I have 1 kgcm as my final torque, because it doubled my 0.5. Since I cut the radius down to half what the kgcm 1 cm, we did 0.5 cm, so it's stronger, because we're hugging closer to the output shaft. So that doubled it to 1 kgcm, whereas his was at 2.8 kgcm. So we've closed the gap by quite a bit. All right, now his speed at this point is 13.6 times faster. So 3 of my N20 motors is 3 kgcm, which is 6.6 pounds of pull force, and 86.3% of his speed. His is 2.8 kgcm, so 7% stronger than mine. No, so we are 7% stronger than his, because we're at 3 kgcm when we did 3 of them, and his is 2.8 kgcm. So we are 7% stronger than his, but we're only 86% of his speed. Now, he loves high-speed fingers. He shows his videos on his Dex V1 and stuff. His fingers move very quickly on his Dex V1 hand. So I don't mind knocking off a little bit of speed if I can get more torque. That's okay with me. I don't need super fast fingers for this particular build, because I'm going for cheaper components. I'm not going to get the best of speed and torque. I got to pick one more so. If you're going to go for best of both, then you need brushless DC motors. They got to be big. They've got to be well down geared, and you open up a Pandora's box of complexity that way, which I'm trying to avoid for this build. Just this build, I want to keep it simple and make it fast. Just learn. Just push through a whole build quickly and bring what I learned to my real build, quote unquote, which is Adam, Eve, and Abel, who are going to be using my idealized designs with full human-like musculoskeletal systems and not so many shortcuts taken, really kind of top of the line, very best you can do type of stuff. Now, as a side note, 3 of these N20s at 6.6 pounds pull. My 2430 motors after 64 to 1 down gear are 27 pound pull. So ultimately, if you read all this, I calculated ultimately it'll take about 12 of these little guys to make one of my 2430 brushless DC motors. But I played around with the numbers, and it turns out about 10 of them can get pretty close, though. Because you got to factor in various things like maybe it wouldn't have to be 64 to 1, 32 to 1 could still work, and stuff like that. So, ballpark, maybe 10 of them is about going to be a similar match. So that's just good to know, because all my calculations for my past robots were based on largely 2430 motors, which I'm using tons of in that robot. And so every time I put in a 2430 in my main robots, if I put 10 of these N20 motors in, we'll get similar performance. So that was a good note to take away. Also, when I put 3 of these to try to match his SC0009, we're taking up a little bit smaller form factor. His form factor was 38/20/40, mine's 30/12/36, so it's significantly smaller, and yet putting out similar speed and more power. So, and it's cheaper. Mine come out to about 80 cents each for 3, so that's $2.40 for all 3. Whereas his, if you bought the servo, would be, I don't know, it was like maybe $10 or $11. However, his will come with the circuitry, but then you also have to buy a serial converter board or something like that, because they take serial commands, and I didn't like that. I just want PWM. The serial command and a converter board, I mean, maybe you don't need a converter board. I don't fully understand it, but I don't like any of that. I just want my microcontroller to directly just turn the motors itself. I don't want a middleman motor controller board that I didn't make doing any decision making at all. None of that. That I don't like at all. So I'm just going to be using a L298N chip. No, L298N motor driver H-bridge chip. It has 2 channels. It can handle 2 amps per channel. So we can run 2 N20 motors per channel, so a total of 4 N20 motors if we use both channels per chip. And those chips are only at like 20 cents if you buy them in bulk. So it's negligible. Alright, so back to what I was saying. I have the Adam, Eve, and Abel robot. You guys knew about that. We've talked about that a million times. This 4th robot, which is supposed to be a compromise between low budget, kind of crappy, and my supreme Omega perfect science fiction level, shooting for the stars level, whatever that I've been doing, it's kind of more in the middle. It's a step down. But it's meant to go quicker and get us a great learning experience to take with us to our luxury model. So this is kind of our budget economy version. Okay. So this budget economy robot needs a name. It's a fresh project. It's one of our 4 robots. It needs a name. The name I'm giving it is Dinah. Since we have Adam and Eve and Abel, Adam and Eve are the mom and dad, Abel's the son. I didn't want to make Cain because he was the bad brother. So Dinah will be one of Cain and Abel's sisters. And I can create as many sisters and brothers as I want. And I can just use any Bible name, but even if it's a Bible name from a different story in the Bible, that character in that story could have been named after one of Adam and Eve's kids. Adam and Eve could have, and most likely did have, probably 50 or 100 kids, because they lived 1,000 years. Um, so there's a ton of kids we can make for them to keep our theme going. And Dinah is the name of Jacob's daughter, I believe. Jacob with Leah had Dinah. And ChatGPT actually helped me pick that name. I just thought it sounded great, so Dinah it is. So I'm making Dinah, so that way I'll have Adam, Eve, Abel, Dinah, two females and two males. So it's a nice 50-50 mix of male to female ratio. Okay, so this is going to be a female robot. Um, and like I said, we're skipping the PVC medical skeleton route for this one, and we're going to go with a simplified skeleton. Now, I was looking at the skeleton design that the Robot Studio had in some of his CAD files for his Dex hand, and I felt it was a little overly complex for what I want. It also had a hard shell design. I kind of would rather just have no shell to it. I'd rather just have some kind of rod for the bone and then just wrap that in tons of motors. Kind of like I'm already doing with the PVC medical skeleton bones. Um, but I'm wanting to have linkages. And after deciding on that, um, in my research, I realized really what could be a great skeletal structure is a pre-made one that's already made that nobody thought would be used for a robot. I'm thinking of repurposing it for a robot, and so I want to show you guys that concept. Um, okay, so this is like a great skeleton in my eyes for a robot. You can wrap all your motors around here. It has every degree of freedom of the human body. It doesn't have fingers, so I have to actually make fingers and toes and stuff. But this is a much simplified version. Now, I don't actually like this. I think the back might need one more joint here so that it can like arch the back or bend the back better. Just having one bend in the back is kind of weird. So I'd maybe want like one here, one here, one here. Maybe divide this into 3 bends. So this little section I'm not okay with. But I guess this is fine. It's a simplification, removing the sacrum and the lower back lumbar area. I think it would just bend down here. I mean, it might look kind of weird. Maybe I'd make this like shorter and then have this have like 4 segments instead of 1. So I will modify this part of the torso, but I feel like the arms, shoulders, wrists is a great simplification. Also, the legs from here down looks fantastic, I feel. I will need probably to have something that rotates here so that it can be more like the arm. I think it rotates right here. And that way the feet can rotate, pronate and supinate the feet. So basically, this is a love doll or sex doll, whatever you want to call it, skeleton. And so I realized this is already made for me. That would be a huge time saver just to use an off-the-shelf skeleton. Just like I was going to use the PVC medical skeleton to save time, this would save me a lot of time just to go with that. So I went ahead and bought a male love doll used on eBay to rob the skeleton from it to use for a robot, and also the raw material of the TPE rubber that it's made of can be repurposed to make any robot design I want, using it kind of like clay. It's just like 70 pounds of rubber. So I could cut it into strips and sew it together. I could fuse it together with a heat gun or a soldering iron. I could even cut it in strips, heat one side, and like glue it onto itself. There's so many things I can do with it. So it would just save me a lot of money in rubber to be able to use that anywhere I want. I can basically make rubber skin for the body with it, and then for making realistic silicone skin over the top of that, I would just add the silicone right on top of it. So it's a great building material that's basically comes for free with the skeleton. Now, since I bought it used, um, I was able to get a great deal. Some woman was selling it. It's a male love doll that the woman sold to me through eBay, and I don't really like supporting that whole industry because I don't like the use of dolls or robots for sexual purposes. I don't agree with it. But since it was used, it's not like the money's going to a company producing that. I don't really want to support them. Um, but I couldn't pass up the deal. Basically, for the price of shipping, maybe a little over that, I got all these free materials. I mean, it's just an amazing deal I was able to get.